property number 1 of the determinants, which states that if all the rows and columns of a determinant are interchanged, the value of the determinant remains unchanged. This is first property of determinants. So, for example, we have a determinant 4, 5, 6, 2, 1, 3, 4, 8, 9. So if we interchange the rows and the columns of the determinant, its value remains the same. So first row becomes first column. So first column will be 4, 5, 6. And the second row becomes second column. So the second column will be 2, 1, 3. And third column will be the third row, 8, 4, 4, 8, 9. So these two determinants are equal. Now here we come to property 2, which states if any two rows of a determinant are interchanged, the value of the determinant is changed by the sign. For example, if the value of a determinant is plus 4, after interchanging two rows, it becomes minus 4, or if the value of determinant is minus 4, after interchanging the rows, it becomes plus 4. For example, we have a determinant 2, 3, 2, 4, 1, 7, 1, 4, 5. So if we interchange any two rows, keeping the third row unchanged, the value of the determinant is changed by the sign. So let's interchange the first and the second row. That is equal to minus determinant 4, 1, 7, 2, 3, 2, and third row remains the same. So this is the second property of the determinant. Now the third property of determinants states that if any two columns of a determinant are interchanged, the value of the determinant is changed by the sign. That is, if the value of a determinant is 4, it becomes minus 4, and if it is minus 4, it becomes 4. So we have the determinant 2, 1, 4, 6, 3, 2, 1, 4, 3. So we may interchange any two columns, keeping the third column as it is. So let's interchange the first and third column, keeping the middle one as it is. We get is equal to minus determinant. Now first column becomes 4, 2, 3, and the middle column remains as it is, 1, 3, 4, and third column 2, 6, 1. So this is third property of determinants. Now we come to the property 4, which states that if any multiple of a row is added to another row, the value of the determinant remains unchanged. And this property is popularly known as elementary row transformation. So we have a determinant whose first row is A11, A12, A13, and the second row is A21, A22, A23, and third row is A31, A32, and A33. So if we add a multiple of any row in any other row, the value of the determinant remains the same. So let us add the lambda times of R1 in R2. So R2 plus lambda R1. So R1 is the operator, so it will remain the same. So A11 A11, A12, A13. And now we have to carry out the operation R2 plus lambda R1. So we get in the second row A21 plus lambda times A11, A22 plus lambda A12 and A23 plus lambda times A13. And now third row remains as it is, A31, A32 and A33. Determinant closed. Now we may carry out the operation on two rows together. So the first row as operator taken as it is, and we have to carry out the same operation on R2. So we get A21 plus lambda times A11, A22 plus lambda times A12 and A23 plus lambda times A13. And now we have to carry out the operation R3 plus mu times R1. So we get A31 plus mu times A11, A32 plus mu times A12 and A33 plus mu times A13. So this is the property number 4. And these are the operations we have carried out in the same step. So the operation may be carried out on two rows together. But remember that no operator may be operand or no operand may be operator. So here R2 is operand and R1 is called operator. In the same way, in the next operation, R3 is operand and R1 is operator. And you will have to keep one thing in mind, which is very important, and that is in the same step, an operand, or we may say an operator, may not be operand and vice versa. So this is property. Now here we come to the property 5, which states that if any multiple of a column is added to another column, the value of the determinant remains unchanged. And this is similar to property 4. This property, or we may say this operation, is popularly known as elementary column transformation, and the process discussed in property 4 and here in property 5 are collectively known as elementary transformation. Let we have a determinant A11, A12, A13 A21, A22, A23, A31, A32, A33. So now we may add any multiple of any column to any column. The value of the determinant remains the same. So now we are taking the first column as it is, and we are adding lambda times of column 1 in column 2. So we get A12 plus lambda times A11, A22 plus lambda times A1, A21, A21, A32 plus lambda times A31. And now we are going to carry out an operation with column 3 in the same step as mu times of column 1 is added to column 3. So we get A13 plus mu times A11 and A23 plus mu times A21, A33 plus mu times A31. Determinant closed. So here we have carried out the operations C2 plus lambda times C1 and C3 plus mu times C1. So this is called elementary column transformation, and it doesn't affect the value of the determinant. Now here we come to property 6, which states that if every element of a row or a column of a determinant is 0, the value of the determinant is 0. So suppose we have the determinant whose first row is 0, 0, 0, second row is 2, 4, 6, third row is 1, 5, 8. So its value is 0 because every element of the row 1 is 0. Similarly, if every element of a column is 0, like 1, 6, 8 is the first column, and second column is 0, 0, 0, and third column is 8, 9, 4, its value is also equal to 0. So here we come to property 7, which states if the elements of any two rows or any two columns are identical, the value of the determinant is 0. So let the determinant is 4, 5, 6, 3, 8, 9, 4, 5, 6. So here we observe that row 1 and row 3 are identical, 4, 5, 6, 4, 5, 6. So its value is 0 by the property 7. Similarly, if any two columns are identical, like 7, 8, 9, 2, 3, 4, 2, 3, 4. So here we observe that column 2 and column 3 are identical, so the value of the determinant is 0. So here we come to the property 8, which states if every terms of a column of a determinant is a binomial, that is expression having two terms, then the determinant can be written as the sum of two determinants such that one determinant has only one term of the binomials and having the rest of the terms as these are. For example, we have the determinant x plus alpha. First column is x plus alpha, y plus beta, z plus gamma. Now here every element is a binomial, and the second column is UVW, and third column is ABC. So here we see every element of the column 1 is a binomial, so this determinant can be written as determinant XYZ UVW ABC, determinant closed, plus second determinant alpha beta gamma UVW ABC, determinant closed. So this is last property of the determinants.